This video will be going over the project developed by the mechatronics students of the fall 2025 semester of the University of Texas at El Paso. The project was developed based on the following quote: "Saving time helps save lives." Our objective for this project was to design and build a medical assistant rover which is able to centrifuge blood on the go, meaning it can go from point A to point B while centrifuging blood and following a line so it keeps track of where it's going. This helps reduce medical staff manual work while ensuring safety, easy handling, and reliability. This project is made up of 3 separate systems. The main system is the rover, which has the following components: a line follower sensor, an ultrasonic sensor, gear motors, and an Arduino Uno R4 for Wi-Fi connection for a user-friendly interface. Next, we have our centrifuge, which is made up of an LCD display, an encoder to control the RPMs, an Illegal Mega R3, and a DC motor that spins the centrifuge. Last but not least, we have our lockbox with an LCD display, a keypad for safety, a servo motor, and an Arduino Uno microcontroller. The rover works in the following way. The rover reads the line sensor and this makes it move forward. If the rover reads the proximity sensor and it detects an obstacle, it will fully stop. If it doesn't, it will continue at normal speed. Once it's been called by a door, it will stop at the door and it will then continue after the time is cleared. Next, we have our centrifuge. It is important to keep in mind that all of the values and data for the centrifuge are displayed on the LCD display. First, it reads the potentiometer. If there's a change in the RPMs, it displays it on the LCD display. If there's a change in the timer, it will also display it. After this, it will read all of the values and then it will start and spin at the time and RPMs that are given. Last but not least, we have our lockbox. The LCD display will prompt the user for a password. If the password inputted is wrong, it will not open the servo. If it's correct, it will open the servo and then the user will be able to open the door. And finally, we have our final prototype. In here you can see the user input the password and see how the servo unlocks the door. It is able to take the stuff out of the lockbox, and after this 10 seconds displayed on the screen, the servo will go back down and lock the door again. This is our user interface. The user is able to access this interface via IP address thanks to the Arduino R4. In here, the user can call for a door and ask the rover to stop for a determined amount of time at this door. Once the ultrasonic sensor reads the rover, it will make the rover stop and it will display a time and clear the door after a specific time. Here you can see how the third door is called and we will see our rover be initialized thanks to that. And as it's moving and the ultrasonic detects the rover fully stops. It now has 15 seconds to either start the centrifuge, open the lockbox, or do whatever the staff needs. And in here, we activated our centrifuge to demonstrate our rover does work while our centrifuge is moving. As mentioned, if there's an obstacle in the way, the rover will fully stop. Our project successfully demonstrated how automation can simplify and speed up routine medical tasks. Since it's designed to transport and centrifuge blood samples on the go, it's able to save time for the staff that would otherwise be spent walking between the collection points and the laboratories. This project showed how embedded systems and mechanical design can come together to solve real problems in healthcare environments. It also showed us the importance of teamwork in engineering.